This is another video in the fundamentals of electrical circuit series. Today what we're going to do is talk about parallel and series resistors. Once in a while it's useful to take resistors, many resistors, and combine them and deal with them as if they were one resistor. This concept is called finding an equivalent resistance. So what we're going to do first is we're going to start working with series. Two resistors is said to be in series if they're connected at one point and we can be sure that the current is same in both of them. Then we can say that R1 is in series with R2, and we can go ahead and extend this and we can keep adding more R3 and many more to Rn. So we can have n of these connected to each other. Let's say this is point A, this is point B. These resistors are said to be in series. Now, if someone comes and shows another branch going out to someplace else, then these no longer would be in series because the current here will not be equal to current here. So in order for resistors to be in series, they have to be connected at one point and have exactly the same current going through both of those resistors. So in this particular case, what I have drawn is actually n resistors in series. By a simple application of KCL and KVL, we can demonstrate that we can actually come up with the resistor we shall call R equivalent, and this resistor can replace all n resistors if that resistor's value is equal to R1 plus R2 plus Rn. Okay, a simple example of this would be if we were asked to find a equivalent for something like this. A, B, this is 10 ohms, 50 ohm, let's not look at ohm, and then 60 ohms. So we can replace all of these resistors with one resistor and still have exactly the same behavior if we just say R equivalent is equal to 10 plus 50 plus 60 or 120 ohms. So that wasn't too bad. So that's what is series. You can have 2 of them, 10 of them, n of them. Really doesn't matter how many. You can use the general formula we provided here to basically, this is the general formula you should take away from this. So if the resistors are in series, we can apply it with that. Now, what if the resistors were in parallel? So how could they be in parallel? Let's take a look at it. In order, so now we're talking about parallel configuration. So if the two resistors are in parallel, that means that they are connected at both ends. So here is, let's say, A and B. So here is an example of resistors connected in parallel. So let's say this is R1, this is R2, and on and on. R3 and many more until we have Rn. So if we want to replace this whole thing with a single resistor, R equivalent, we'll talk about in a minute how to do that, but let's go back and complete thought that in order for two resistors to be in parallel, they have to be connected to each other on both respective ends, or if there are more, all of them have to be connected to each other on one end and the other end to each other. And the voltage across all of them will be exactly the same. Doesn't matter which resistor you measure the voltage, whether it's here, it's going to be V, whether it's over here, it's going to be V, and it's all going to be the same. So in order for resistor to be in parallel, two things have to be true. If you're ever in doubt, check those. The resistors have to be connected each end to each other at both ends, and the voltage across both of them have to be exactly the same. So you might ask, when would that not be true? If there was a resistor, let's say place it here, or the voltage source place it here, these no longer be in series, in parallel. So how do we find it? The most general form of finding the R equivalent is if you use this simple equation which says R 1 over R equivalent is equal to 1R1 plus 1R2 plus 1 over Rn. That's a relatively simple, complete equation when you have a parallel circuit. So let's do a couple of examples. Parallel is a little more involved than series, so let's do a couple of examples. So let's say I come up to you and say, okay, you've got a 10 ohm resistor here, and you've got a 10 ohm resistor here, and let's say you've got a 5 ohm resistor in here. And these are all resistors, and this is point A and point B. And you're being asked, can you find an equivalent for that? You say, sure we can, because they are in series. They're all, one side are all connected to each other, and the other side is all connected to each other. Nothing in the middle, so this voltage from here to here is the same as here to here, and on and on. Okay, so now how do we find? So we say that we have 1 over R equivalent is equal to 1 over 10 plus 1 over 10 plus 1 over 5. So common denominator, many ways to solve it. We'll take a common denominator of this one. We will have 10 on the bottom, and then we'll have 1 plus 1 plus 2, which this becomes a 4. So you can have 2 over 5 Siemens, which is the unit for 1 over R. Anyway, so R equivalent is going to be 5 over 2, or 2.5 ohms. Pretty straightforward. Over time, you'll see some special cases. It's always good to know that. For example, if I have a resistor, let's say 100 ohms, and I have another resistor, 100 ohms, then the question is, what is R equivalent? And this is a special case because they're exactly equal. Over time, you'll find out. You still can plug it in that equation if you want, but you will find that R equivalent in this case is just going to be half, which is 50 ohms. Yeah, it's kind of a special case. The other interesting case would be, hey, what happens if I have a resistor 100 ohm and I have a short across that? So now you want to think about it. What is short? What is R for the short? Well, R for short is 0 ohms, which basically says if I apply the equation we just learned, it would be R equivalent is equal to 1 over R equivalent is equal to 1 over 100 plus 1 over 0. Now we know 1 over 0 is really infinite. We're in engineering, we're not in math, so we can't say undefined, which means 1 over R equivalent is equal to infinite, which means R equivalent is equal to 0. That's kind of interesting. That means if you got a short across any resistor, the result is a short. So as if this didn't exist at all. That's kind of useful to have. That brings us to the end of the two things you need to know. Now, are there possibilities where we would not have resistors in series? You bet. Sometimes it's kind of deceiving. This is a very common configuration. This is referred to as, and they might have a connection here, A, B, and C. And so there are 3 resistors here. This is referred to as a delta, kind of look like an upside down delta, or sometimes is also referred to as a pi because it's kind of look like a pi as well. If it's pi, if we draw it squared, it would kind of look like a pi, like this. Where let's call this one R1, R2. So that's one possibility, and as you notice, this could be R1, R2, R3. So that's why they call it Y, or they call it pi or delta configuration. This one is neither in parallel nor in series because there could be each one of these you need to keep intact. These, although sometimes it's easy if you have these to convert them into a Y configuration. So there is a configuration that look like this, where this is C, this is A, this is B, this is R1, this is R2, and this is, let's say, R3. This is referred to as Y or T. Of course, if you get these hands down, this branch and this branch down and draw it horizontally, it will look like a T, and that's why they call it. So this is a configuration. We don't spend a lot of time in these kind of configuration. Most of the places what we see is either parallel and series, but it's always good to know this option is available to you if you need to. That brings us to the end of the series and parallel resistor equivalent. What is really important for you to take away from here is if you what is required for something to be in parallel, and once you've decided yes they are connected in both ends and the voltage is the same across the resistor, then you can use this equation right here to find the R equivalent. In the case of series, of course, as when the resistors are connected on one end and they have the same current through both of them, then you can say they are in series, and you simply add the values to get the equivalent value. And that brings us to an end of this video.